We continue the lesson with topic 2, solution, and rate of solubility. To understand the solutions, and rate of solubility, we need to first know about the concept of solute, solvent, and solution. A solution is a mixture formed when a solute dissolves in a solvent. Solutes are substances that can dissolve in liquids. A solvent is a liquid that can dissolve solutes. A solution has varying concentration, depending on the ratio of solutes to solvents. When the ratio of solutes to solvent is higher, the concentration of solution becomes higher. A solution can be classified into 3 groups, according to the ratio of solutes to the solvent. They are: dilute solution, concentrated solution, saturated solution. A dilute solution is a solution with a low ratio of solvent, it can dissolve more solute. A concentrated solution is a solution with the high ratio of solutes to solvent. It can dissolve a little more solutes. A saturated solution is a solution with the maximum ratio of solutes to solvent. It unable to dissolve any more solutes. This topic is solution and suspension. A suspension is a cloudy mixture formed from solutes that do not dissolve in liquid. A solution is a mixture formed when a solute dissolves in a solvent. Both solution and suspension are mixtures. The difference between them is, a solution contains dissolved substances, while a suspension contains undissolved substances. The following are the detail about solution. In solution, solutes are dispersed evenly in solvents. It is homogeneous color and uniform appearance throughout all part of the solution. A solution may be colorless or colored. However, the uniform color causes the solution to look clear. Solutions are transparent because the tiny solutes particles allow the light to pass through. Solutions do not leave remnants when filtered. Solutions do not leave remnants when filtered. The following are the detail about suspension. When the solutes do not dissolve in liquids, the mixture becomes cloudy. This is a suspension. The particles of suspension are too big and do not allow light to pass through. A precipitate will form at the base if the suspension left for a while. And suspension leave remnants when filtered. This topic is about the solubility of solute in a solvent. Solubility is the maximum quantity of solute in gram unit that can dissolve in a 100 ml solvent at a specific temperature. The formed solution will be a saturated solution. Solubility is the capability of a solute to dissolve in a solvent at a specific temperature. The solubility rate of a solute in a solvent is the measure of how fast the solute dissolves in a solvent. The solubility rate of a solute in a solvent is influenced by 3 main factors. The first factor is the temperature of solvent. The second factor is the total surface area of solute exposed to solvent. The third factor is the rate of stirring. These 3 factors will be detailed in the coming section of the lesson. About the first factor, the temperature of solvent. When the temperature increase, the rate of solubility increase. This is due to when the temperature increase, the molecules of the solvents gain more kinetic energy and move faster, which increase the speed of solubility. About the second factor, the total surface area of solute exposed to solvent. When the total surface area of solute exposed to the solvent increase, the rate of solubility increase. This is because more molecules of the solute contact directly to the molecules of the solvent. When the same amount of solutes broken down into the smaller pieces, the total surface area exposed to the solvent increase. Hence, the rate of solubility increase. About the third factor, the rate of stirring. When the rate of stirring increase, the solubility rate of a solute in a solvent increase. The time for solute to dissolve into the solvent becomes shorter. Stirring keeps solute particles in motion. which increase the transition between solute particles and solvent particles. At the meantime, this causes the mass transfer rate to increase, hence faster dissolution rate. This topic is colloid. A colloid is a mixture of two or more solutes that dispersed evenly in a solvent. A colloid is a mixture that doesn't produce a clear mixture, nor sediment. It falls in between a solution and a suspension. Such a difference is due to the particle's size of solute in colloid falls in between the particle's size of solute in suspension and solution. The following are the types of colloids. Aerosol, it is a mixture of a solid or a liquid dispersed evenly in a gas. For example, smoke, it is a mixture of a solid dispersed evenly in a gas. Dust, it is a mixture of a solid dispersed evenly gas. Mist or fog, it is a mixture of a liquid dispersed evenly in a gas. The second type of colloids is emulsion. Emulsion is a mixture of a liquid dispersed evenly in a liquid. Milk, coconut milk, and fish oil are the examples of emulsion. The third type of colloids is solid emulsion. Solid emulsion is a mixture of a liquid dispersed evenly in a solid. Jelly, pearl, and opal are the examples of solid emulsion. The fourth type of the colloids is foam. Foam is a mixture of a gas dispersed evenly in a liquid. Cream and soap suds are the examples of foam. Solid foam is the fifth type of colloids. Solid foam is a mixture of a gas dispersed evenly in a solid. Marshmallow and styrofoam, examples of solid foam. The sixth type of colloids is sol. Sol is a mixture of a solid dispersed evenly in a liquid. Ink and paint are the examples of colloid. The seventh type of colloids is the solid sol. Solid sol is a mixture of a solid dispersed evenly in a solid. Stained glass and black diamond are the examples of solid sol. This topic is water as a universal solvent. Water is a universal solvent because it can dissolve almost all substances, whether solids, liquids, or gases. The aqueous solution is the solution with the water as the solvent. Water is used as a domestic solvent, and also the raw material in manufacturing, agriculture, and medical industries. The following are the examples of the use of as the solvent. Dissolving detergents used in the washing and cleaning. Dissolving fertilizers, to enable them to be absorbed by the roots of plants. Dissolving chemical substances in the laboratory. The advantages of water as a solvent over the other solvents are: water is easily available, cheaper, and safe to manage. Beside water can be acted as the solvent, there is another type of solvents called organic solvents. The substances that cannot dissolve in the water will dissolve in organic solvents. An organic solvent is an organic compound containing carbon elements that can be used to dissolve solutes. The following are the examples of organic solvent. Alcohol is any organic compound in which the hydroxyl functional group, OH, is bounded to a carbon. The R in the is a chain of carbon atoms. There are many types of alcohol as shown in the table. About the uses of alcohol. Alcohol can be used as antiseptic. Alcohol can be used to produce perfume and to produce polishing liquid. Acetone is the organic compound with the formula CH3, 2-Co. It is a colorless, volatile, and flammable liquid. Acetone can be used to produce nail varnish, lipstick. Amyl acetate is an organic compound, with the chemical formula CH3CH24CH3. Amyl acetate can be used to produce nail varnish, lipstick. Benzene is an important organic chemical compound, with the chemical formula C6H6. The benzene molecule is composed of 6 carbon atoms in a ring, with 1 hydrogen atom attached to each of the carbon atom. Benzene can be used to remove stain of oil and grease and dissolve rubber. Chloroform. Chloroform is an organic compound, with formula CHCl3. It is a colorless, sweet-smelling, and dense liquid. Chloroform can be used as the solvent for oils, rubber, and waxes. Ether. Ethers are a class of organic compounds that contain an ether group, at which an oxygen atom connected to 2 alkyl or aryl groups. Ether can be used to extract oil. Kerosene, also known as paraffin, lamp oil, and coal oil. Kerosene is a flammable liquid. It is a mixture of compound from C10H22 to C16H24. Kerosene can be used as fuel oil lamp and remove the paint, oil, and grease stain. Turpentine. Turpentine is a fluid obtained from the distillation of resin from live trees, mainly pines. Turpentine is used to dilute and remove paint and varnish. This is the full content of Topic 2, Solutions, and Rate of Solubility.